Now, time to move on to permutation and combinations. Most students find this topic the hardest, including me. I struggled with permutation combinations last year. It's all about logic, and the more you practice, the more amount of questions you do, the easier it becomes. If you just do one or two questions and then expect to get all the questions right, that's not going to happen. So you're going to have to practice a lot. More than me explaining the concept, I think it would be beneficial if I work through problems because that's how you understand permutation combinations. Even if I explain the theory, you'll only understand how to manipulate the things, how to use permutations while we do the questions. So it's fine if you don't really understand anything when we just do the theory part. A permutation of a group of symbols, my love, is any arrangement of those symbols in definite order. One thing you're supposed to know is that permutation deals with arrangement. Sorry, one second. With arrangement, order, etc. Anytime you see the word arrange, order, or anything along the lines of these, you're supposed to know that you're supposed to use permutations. The difference between permutation and combinations is that permutation deals with arrangement and so on, while combination deals with selecting certain things. In permutations, the order of things that you put in a line or you choose, it matters, but in combinations, it does not. I'll give you an example. So imagine we have A, B, C. Let's just take a very simple example. So let's say we take two and we arrange them. So let's say A, B, A, B, B, C, A, C. This is the combinations, three. You can't do anything else. Even if you choose B and A, you're gonna end up with the same thing. If you choose C and B, it's the same thing. But for permutations, it can be B, A also, because like I said, order matters. The arrangement of these matters. And therefore, permutation deals with arrangement, ordering of things, and combination deals with selecting items. Okay, for example, BAC is a permutation on the symbols A, B, C. In all of these, three of them are used, and we say the symbol are taken three at a time. The set of all the different permutations on the symbol A, B, C, taken three at a time, no, it's three, but I used two, is ABC, ACB, BAC, BCA, CAB, and CBA. So suppose we want to find the number of different permutations in the symbols A, B, C, D, E, F, G, taken three at a time. So there are three positions to fill. The first one, second one, and third one. So the first position can be filled in seven different ways, and the second one in six, and then this five. And now we use the principle, the product principle, to find this. So it's going to be 7 into 6 into 5. So that's how we get this. And remember we saw NCR, right? There's something called as NPR. P deals with permutation. So the number of permutations on n distinct symbol taken r at a time is n factorial divided by n minus r factorial. So let me give you an example. We have 5 chocolates, 5 different types of chocolates. Okay, it's not writing. Okay, and now imagine we take 2 at a time. what would be the number of ways we could do this in? So let's apply this formula. It's going to be 5 factorial divided by 3 factorial, which is 5 into 4, which is 20. So this is how you do it. I hope this is clear. And now let's just move on to the questions. The first question, in how many ways can 5 different books be arranged on the shelf? It's 5 books taken 5 at a time. So it's going to be 5 factorial divided by 5 taken 5 at a time. So 5 minus 5 factorial, which is 5 factorial divided by 0 factorial. Do you remember why we define 0 factorial as 1? It's for this. Because if 0 factorial was 0, well, this would be undefined. But that's not the case, right? It's going to be 5 factorial divided by 1. So that's why 0 factorial is 1. It's just for convenience sake. So this is going to be 120. Okay, the next question. 3 different paintings can be chosen from a collection of 8 hung in a row. So 3 from 8. So 8, it's going to be 8 p 3. So 8 factorial divided by 5 factorial. It's going to be 8 into 7 into 6. This is going to be 336. Now the next one. A signal consisting of 4 colored flags in a row be made if there are 10 different flags to choose from. It's going to be 10p4. It's going to be 10 factorial divided by 6 factorial. It's 10 into 9 into 8 into 7, which is 5,400. Let's check the answer. 120, yeah, and yeah. And then now let's do the second question. A captain and vice captain are to be selected from a team of 11 cricketers. In how many ways can this be done? Alright, so there are 11 people in the cricket team. So 11 available. And a captain can be chosen from 11. So 11 into, there are 10 options. So it's going to be 110. Let's see the answer. Yes, that is indeed the answer. 3-digit numbers are constructed from the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, using each digit at most once. How many such numbers can be constructed? We have 3 digits. So the first can be occupied by 9 digits, because if we put 0 here, then it's going to become a 2-digit number. And therefore, this can be filled in 9 ways. And this can also be filled in 9 ways, because it can be occupied by 0. And this is going to be 8. So 9 into 8 into 9. That is going to be 648. So that's the answer for A. And now B. They end in 5. Similar to this question. It's very similar, but it has to end in 5. So this can be occupied by 1 digit, which is 5. And the first one cannot be occupied by either 0 or 5. So it's 8. Then this is going to be 8 also, because we have 5 here and we have some other number here. So it's going to be 8 into 8. So it's 64. And C, it ends in 0. This can be occupied in one way, this 9 and this 8. This is 9 because 0 is already here and we don't have to worry about that. So it's going to be 9 into 8. That's 72. And are divisible by 5. As you might know, if a number is divisible by 5, it means that it either ends in a 0 or 5. And we've already found out the possibilities, the number of ways that it ends in 5 and it ends in 0. So we just have to add them. So it's 64 plus 72, which is 136. So that's the answer. Let's verify this. Yes, that's also what we got. And now consider the letters of the word Monday, Monday. How many permutations of 4 different letters can be made if there are no restrictions? If there are no restrictions. We have the word Monday, and we are selecting 4 from the available 6 letters. It's gonna be 6p4, which is 6 factorial, divided by 2 factorial. This will be 6 into 5 into 4 into 3, which is 360. And we have to find the number of ways in which the vowels, it uses at least one vowel. So it's going to be the total number of ways minus the number of ways in which they're not there at all. So it's going to be 4 factorial. Which is 360 minus 24, which is 336. The last question, the 2 vowels are not together. So the total number of ways is 360. And we have to find the number of ways in which they are together. Therefore, it's going to be 4p2 because we're selecting 2 from the available 4, which are not vowels, into 3 factorial. It's going to be 360 minus, it's going to be 12 into 6. It's 360 minus 72, which is 288. So the first answer is 360, the second is 336, and the final answer is 288. Let's check the answer. That is also what we got. And with that, we're done with permutation. Try to solve a lot of questions from the book, from the past papers,